This is a super fast review about linear and quadratic functions. Linear functions and quadratic functions. So in this video, I am assuming that you have studied before. So I'm going to focus on the workout solutions. Okay, so pay attention. First, we have these lines from 2 points. Remember, we have a formula when we need to find the slope. The slope, we have 2 options. The slope, it could be positive or negative. Okay, when the slope is positive, is because the line is going up, is upwards. When the slope is negative, is going downwards. Okay, so basically we have these 2 options. Then if we want to find the slope, we can use this formula, y2 minus y1 divided by x2 minus x1. And then there are many ways to represent a line, a linear equation, but this is super popular. This is the slope and y-intercept form. Okay, because if you remember, the m, the number next to the x, is the slope, and then b is the y-intercept. Okay, so this is super important. So what happens when we have this situation? The graph, number one, the graph of a line passes through the points, and then we have to find the slope. So every single time that we already have the points, and remember, a point has always coordinates x, comma, y, always. So here we have x, y, x, y. Okay, so find the slope. So here we can label this like x1, y1, x2, y2. Okay, it doesn't matter if you label this in the opposite way. It doesn't matter. What matters is to follow the formula. If we have find the slope, we have the slope is y2. What is y2? This one. This number is y2. So we have 10 minus y1, in this case 4, divided by x2 minus x1. So x2 is 3 minus 1. Okay, so we need to be careful with the signs. So remember, we are following this formula. Okay, paying attention to this y2, x2, y1, x1. So what is this? According to this, 10 minus 4, this is obviously 6 divided by 2. Okay, so then the slope m is going to be 3. That's it. So the slope is 3. Okay, well, so we have this. Ground the equation in the slope intercept form like this, following this structure. So we already have the slope, and then we can have y, x by using these points. Okay, so but we need to find the y-intercept. Okay, we need to find the y-intercept. So pay attention. First, we need to choose either this point or this one to do the following steps. So we can choose, for example, the points 1 and 4. Okay, the coordinates 1 and 4. So let's use this one using 1, 4. Pay attention. If we substitute these values, and remember, this is x, this is y. So if we use here the y and then here the x, okay, look what happens. We can have this. What is y? 4 equals, what is m? I am following this. What is m? M is 3 times, what is x? 1 plus b. So by doing this, I'm going to find the y-intercept, this b. So I can say 4 is going to be 3 plus b. Okay, 3 times 1 is 3. So we are going to isolate b by performing the opposite operation. So this number 3 we need to move this number 3 to the left side by using the opposite operation. In this case, the opposite would be a subtraction, like this. So 4 minus 3 is going to be 1 equals b. What is the meaning of this? That the y-intercept has to be 1. Okay, so we can write down the equation, because remember this says write the equation in the slope-intercept form. So this will be something like this. We need, remember, this is the equation mx plus b, but now we have what is y equals, what is m? Remember, m is 3. Okay, so m is going to be 3 times x plus 1. Okay, this is the equation that represents the line, because we are using our slope and this y-intercept. Okay, so that is this, write the equation in the slope-intercept form. Find the y-intercept. Okay, this is easy peasy because we already have the y-intercept. What is the y-intercept? Obviously, according to this, is this one, 1. Okay, so now find the value of y, this one, find the value of y when the x is 5. So basically, if we have this equation, it's telling you find y when x is 5. So we need to substitute this one, x equals 5 here. So we have y is going to be 3 times 5 plus 1. So y is 15 plus 1, and this is 16. And that's it. So this is the solution, the worked solution of the problem number 1.1. Okay, then we need to check what is happening with these linear equations in standard form. Okay, let me see. So here, when we have a linear equation like this here, as you can see, we don't have the slope and y-intercept form. Okay, so if we need to find the slope, because here we have identified the slope and identified the y-intercept, what we need to do here is to modify, to rearrange this equation to have this structure, to have mx plus b. How? We need to isolate y. Okay, so if we have this 4 times y minus 8x equals 16, we need to isolate y by performing the opposite operation. So we have 16 plus 8 times x. Remember, this is a subtraction. Now it becomes an addition. It's the opposite. Then what else? Okay, then these 4, we need to move this 4. Here is multiplying, so the opposite operation is a division. So we have y equals 16 divided by 4 plus 8x divided by 4. Here we can simplify. 16 divided by 4 is 4 plus 8 divided by 4, 2x. Okay, here, so this one is the slope-intercept form. Okay, so if you want, you can rearrange this like this, 2x, like 2x plus 4. It's going to be the same. Okay, remember, the number next to the x, this number is the slope. This one is the y-intercept. Okay, so this is slope, this is y-intercept. So here identify the slope. Here the slope is 2. Identify the y-intercept. The y-intercept is 4. Okay, sketch the graph and label at least 2 points. Okay, so in order to sketch the graph, we need a table. Okay guys, so continue with this example, sketching the graph. If you remember, this is our equation. So we need to build a table like this, this table. So then we can choose points. Usually we can choose 5 points using negative and positive values because we are going to sketch the graph. This is, remember, x, this is y, the vertical axis. So what we are going to choose is values from x, okay, this axis. Then we are going to substitute the x in the original equation. So for example, if I say I want to use maybe -2, -1, 0, 1, 2, okay, so here we need to find the value of the equation, the function. So when the x is -2, we have something like this: 2 times -2 plus 4, and this is 2 minus 2 minus 4 plus 4, so this is 0, okay, 0. Then what happens when we have x equals -1? So we have 2 times -1 plus 4, and this is a positive 2, okay. Then when the x is 0, 2 times 0 plus 4, so this is 4. Then 2 times 1 plus 4, this is 6, and 2 times 2 plus 4, this is 8. Okay, so the most important thing here is these results and also this one. Okay, so pay attention. We are going to identify here, we are going to identify these coordinates using this axis. So when the x, pay attention, when the x is a -2 here, at this point, what is y? Y is 0. So we have the first point when the x, let's use red, this one. Then when the x is -1, we have y equals 2. So this is -1, then y is 2, so we have this point. Then when the x is 0, y is 4, so we have this one, okay. Then when the x is 1, we have y equals 6, this point. Then finally when the x is 2, we have x equals 8, so it's going to be here. Then we can draw the line like this, and this is sketching the graph. Okay, so please remember that we need to check the x-axis and then the vertical axis. Okay, and that's it. Qualities. Okay, in this case, guys, we need to remember that every single time that we multiply or divide by a negative number, we need to reverse, we need to change the inequality sign. Remember, we can have these signs like this one, or this one. So we need to change, to reverse the equal sign, sorry, the inequality sign. So for example, let's use example this one. If we have -2x plus 1, we can solve for x. Solving an inequality is like an equation. So we have -2x plus 1 is smaller than 9. We are going to isolate x, okay. We need to isolate x. So we have -2x is smaller than 9 minus 1, okay. So the opposite operation, this is an addition, now it's an subtraction. So we have -2x smaller than 8. And finally, here comes the trick. We need to isolate the x. So we need to perform the opposite operation of this -2. And this is a multiplication, so the opposite will be a division. So we have x, okay, 8 divided by -2. And here comes the trick. What happens when we divide by a negative number? So we need to flip, we need to reverse the equal sign like this. Okay, so 8 divided by negative 2 is a minus what? Minus 4. And that's it. That is the trick when we have inequalities. Then guys, when we have write the solution in interval notation and graph it on a number line, we need to remember this. We have these situations. When we have these inequality signs, they are related with these symbols, okay? Or when we have smaller or greater, we have parentheses, okay? So interval notation is a way to represent this inequality, but using this, okay? So first we have is greater than, okay? So pay attention, this means that the x is greater than negative 4. Okay, so the interval notation will be something like this. First the negative 4, because it's okay, this is greater than, but also if you remember, we need here a value here. So what is the value? This is greater than minus 4, but less than what? What would be this value? So greater than 4, negative 4, sorry, until what? Until the infinite, okay? So because we cannot touch or reach the infinite, we use parentheses. So this is infinite. Then to graph this using a number line, we need the number line like this. Then we need to identify, and this is 0. What is the negative 4? So maybe here. Okay, so we can say greater than minus 4, and remember, when we have the number line, we have two options. We can use open circle or close circle. Okay, so when we have, okay, we can use this. When we have these situations, this one, something like this, we use the closed circle. When you have these situations, we use open circle. Okay, so obviously in this case we have the situation. So here using the number line, we are going to use open circle to say that this is greater than minus 4 until what? Until the infinite. Okay, so we use the arrow to say that this is the infinite, and that's it. Then simplifying expressions, this is super easy because we need to multiply, basically to use algebra. If we want to do this one, we need to multiply 4 times 3x, then 4 times negative 2, and then simplify. So for example, 4 times 3x, we have 12x. 4 times negative 2, minus 8. Then minus 5x plus 1. So here we need to simplify like terms. For example, 12x and negative 5x. So we can simplify them. We can say 12 minus 8, sorry, minus 5. Okay, and this is, so this is, okay, 7x. Then we have minus 8 plus 1, minus 7. And that's it. So this is easy peasy. We have linear equations, but using context or real life situations. So we have a plant, is 12 centimeters tall and grows 4 centimeters per week. Okay, so what we need to remember is that the slope is the rate of change. And what is the meaning of this rate of change? Is when something is increasing or decreasing by a certain amount every single time. And that is the meaning of the slope. So when we have a plant is 12 centimeters tall and grows 4 centimeters per week, write a linear equation for the height after W weeks. Okay, so because here we are using height and weeks, first remember this is the equation for any linear equation, but in this specific case we are using height, so we can use h to represent the height, the y, equals, what is the slope? The slope is the thing that is increasing or decreasing, the rate of change. What is changing here? The growth, and this is growing, so it's increasing. This means that the slope has to be positive. Remember, the slope is positive when something is increasing, or negative when it's decreasing. So we can say this is a 4 times what? What will be the x? X is going to be the week. Every single week is changing by 4 centimeters. So we can say 4 times W, 4 times the week, 4 centimeters per week, okay? Plus, what is B? The y-intercept, the initial value of this plant. What is initial value? 12 centimeters. 12 centimeters. So this represents this situation. State the slope and its meaning. Okay, so state the slope. What is the meaning of the slope? We already know that this is the rate of change, but used in this context is it is growing 4 centimeters per week, and that's it. Then state the y-intercept. According to this is 12. Okay, the y-intercept is going to be 12 centimeters. But what is the meaning? The meaning is the initial height. Okay, the initial height or the initial length. Well, in this case, it will be better height. The initial height of the plant. Okay, initial height. Then when we have predict the height after 5 weeks, this means that use your equation. If you remember, this is the equation 4 times week plus 12. This is our equation. So it's telling you, use your equation when the height, when you have weeks equals 5. Okay, we are going to find the height when the weeks are 5. So basically we have this. The height is 4 times 5 plus 12. So the height is 20 plus 12. The height is 32. We need to check, I suppose that this is centimeters, and that's it. Okay, then guys, this one, factoring quadratic expressions. Okay, here comes the trick. We have x squared plus 7x plus 10. Always we use two factors. How we're going to find two factors that their multiplication is going to be this. Okay, so this is super easy. Always when we don't have a coefficient here, the first value here is going to be x, because if we multiply x times this x, we will get x squared, obviously. So what is the trick? Well, we need to find two numbers. Here, two numbers that their multiplication is 10. Okay, multiplication is 10. Here, let's say this is the multiplication, but at the same time the addition is 7. Okay, so we need to think, and by the way, you need to be careful with the sign, because this is positive 10, positive 7. So this means that we need two positive numbers. So it could be, for example, what about 5? 5 and 2, positive. So we can check. If we multiply 5 times 2, this is 10. The multiplication is correct. The sum, 5 plus 2 is 7, and that's it. So this is the trick when you are factorizing. This is identifying the roots and vertex, because here is something Super easy because we have a parabola crosses the x-axis at x minus 1 and x equals 3. Okay, so we have this information, this and this. We need to remember that when we have these two shapes. This is when the parabola is negative and this is when it's positive. Okay, so we can say opens up and opens down. When we have the situation, this is a maximum, the vertex, and this is a minimum. Okay, so basically this is something very theoretical, because when we have what are the roots, we need to remember that the crosses the x-axis, when the parabola or the function crosses the x-axis, is the same as roots. We can say zeros of the function, roots, x-intercepts. So what are the roots? Easy peasy, x equals minus 1 and x equals 3. Okay, because here we have the x-axis, well, the parabola crosses the x-axis, so basically these are the roots or zeros, or what are solutions or roots. Okay, what is the vertex? So here is telling you its lowest point. Lowest point means the minimum point. Okay, so the minimum point is at 1 comma minus 4, and that's it. So this is only a different way to say find the minimum, because it's telling you find the, well, its lowest point is that, so you need to think that this lowest point means the vertex, and the vertex is a minimum. So this is at 1 comma minus 4, easy peasy. When we have find the roots, vertex, and graph, first, to find the roots of any quadratic equation, in this case, let's do the first one, x squared plus 2x minus 15. Okay, remember, we are going to find the two factors. Okay, we are going to factorize this. And remember, we need to find two numbers that their multiplication is 15 and the sum is 2x. Okay, so 15, but at the same time is 2x, the sum. So we can say, we need to think, it could be 5. What about 5? Let's see, a positive 5 times a negative 3. Okay, this way, if we multiply 5 times negative 3, it's a negative 15. If we sum 5 minus 3, it's 2. So this is the factorization. Okay. Okay guys, so in this case, here we have the two factors. Okay, so what we are going to do is to set each factor. This is the factor 1, the factor 2. We are going to set each factor equals 0. Okay, so we take x plus 5 equals 0, then x minus 3 equals 0. Then here we need to isolate. Here, where's my pen? Here, isolate x. Okay, so if we isolate x, we must change the sign, this one. So this is a positive 5, it becomes a negative 5. Okay, this would be root number 1. This is the root 1, then this is the root 2. So this, in this case, we need to do the same. In order to have the x by itself alone, we need to move the negative 3, and then it becomes a positive 3. Okay, and this is a positive 3. So these are the roots. Every single time that we need to find the roots, we can use factorization like this, and then set each factor equals 0, then solving for x, and that's it. We have the roots. Then, when we have this situation, find the vertex, we have two options. The first one, the vertex is the point, or is the midpoint, the point that is in the middle, between the roots, the point that is between minus 5 and 3. Okay, so in this way we can find the axis of symmetry and then find the vertex. But also we have a formula for finding the axis of symmetry. This is the way that I'm going to do it. To remember how to use this formula. This formula is for finding the axis of symmetry. So what is B, what is A? If you remember, this is the quadratic equation form or the structure. So the number next to x squared is a, next to x is b, then this one without x is c. Okay, so we need to check what is b, the number next to x, in this case 2. That is the reason that I have 2. Then what is a, the number next to x squared? Here we have an invisible one, okay? So by doing this, we have 2 divided by 2 times 1. So this is a negative 1, okay? A negative 1. What is the meaning of this? This is the axis of symmetry. Okay, this one is the axis of symmetry. Then, once that we have the axis of symmetry, we need to use this x in the original function. What is our original function? Let me copy this. This one is my original function. Copy, then we can paste this. Paste. Okay, this is my original function. So guys, we are going to use this x equals 1 here in the x, in every single x. Okay, so pay attention. We have minus 1 squared plus 2 times minus 1 minus 15. Okay, this would be, this is super important, the y coordinate of the vertex, because the vertex is a point. It has x and y. Okay, so by doing this, we are going to find the y coordinate. Okay, so here we have the x coordinate, and by using this, we can find the y coordinate. So we have y minus 1 squared is 1, minus 2 minus 15. Okay, so basically this is like y equals 1 minus 17 equals 2 minus 16. So this is the y coordinate. So we can be super sure that the vertex is at minus 1 comma minus 16. And that's it. This is the vertex. This is the proper way to find the vertex.